So this is lesson 5, applying the trigonometric ratio. When we solve a triangle, we find the measure of all the angles and the lengths of all the sides. To do this, we use any of sine, cos, and tan. We use Pythagoreans, and we use the fact that the sum of all interior angles of a triangle is 180 degrees. So let's just head right into it. Find all unknown angle measures to the nearest tenth of a degree. I need to find angle F, and I need to find angle D. I'm kind of putting these organizers at the top so we can kind of clearly see what's going on here. Now if I look at angle F, let's make an organizer. Opposite of angle F is 5, and adjacent to angle F is 9. So using opposite and adjacent, looking at SOHCAHTOA, the only one that we can use is tangent. So we're going to say tan of F is equal to the opposite 5 over 9. And I need to isolate F, the variable, by itself. So we have to take the tan inverse of both sides, which leaves us with F is equal to tan inverse of 5 over 9. We plug that into our calculator, making sure to do our check of tan 45 to make sure that equals 1. Shift tan 5 divided by 9, close the bracket, you get 29 degrees. And that gives us to the nearest degree. For angle D, there are two different ways that we could do this. Angle D, we could do another trig ratio, opposite being 9, adjacent being 5. Use our tan inverse of 9 over 5. To get us 61 degrees. Or we can use the triangles all equal 180 degrees. So 180 minus 90 minus, what did we find for angle F? 29. And this is nice because this way it's just like a secondary check. So these answers are the same. This works. This is a good way to do it too because we're not relying on any calculated values for ourselves. And if we wanted to find line segment DF, we'll just throw it in there. That's an angle. And DF is the hypotenuse, so we can use Pythagoreans. So a squared plus b squared is equal to c squared. 5 squared plus 9 squared is equal to c squared. 25 plus 81 is equal to c squared. 25 plus 81 is 106 for c squared. Square root both sides. And that leaves us with 10.29. We'll leave it at 10 because all other line segment measures are to 1 full degree, so we're not degree measurement, so 10 centimeters I think it was is equal to c. Yeah, so that tells us this is 10. So this means we've actually solved this triangle because we found all the angle measures and all the side lengths. Let's do another one here. This is find all unknown side lengths to the nearest tenth of a meter. What we're going to do actually is we're just going to find all the missing bits. So we're going to find here. We're going to find here. And we're going to find here. And then I'm going to write it out too. I'm looking for line segment PR. I'm looking for line segment PQ. And I'm looking for angle Q. Now I'm probably going to start at angle Q because that's going to be the easiest. Angle Q, we're going to use the fact that all triangles equal 180. So we're just going to go 180 minus 76 minus 90. That should give us 14 degrees, which makes sense. That's a pretty small degree there, right? Got to use a little bit of logic here. So let's look at PR. We're going to start with angle R is equal to 76 degrees. I don't know my opposite. That is my PQ. My adjacent is my PR. And my hypotenuse is equal to, it's making me really nervous. What is it doing? Is equal to 24.3. So using this, what we're going to do is we're going to use our cosine and our sine in order to not use any of our calculated values. So we're going to go sine of 76 is equal to PQ over 24.3. We're going to cross multiply by setting this over 1, drawing some arrows. So this gives us 24.3 times sine 76 is equal to PQ. We plug that into our calculator exactly as it looks. That gives us, to the nearest tenth of a meter, 23.6 meters is equal to PQ. And I label that here, or you can label it over here so you know where it should be. And this makes sense, right? Like RQ should be the longest side, and PQ should be fairly long, but it cannot be longer than this side because this is the hypotenuse side. Our next one that we're going to do here is we need to find PR. So that means I need to use my adjacent, so I'm going to use cos is equal to PR over 24.3. We're going to cross multiply. And that gives us 24.3 times cos 76 is equal to PR. RP, PR, same thing. 24.3 cos 76. We should get 5.9 meters is equal to PR. And again, that makes sense because that side is super small in comparison to these sides. Kind of using logic and reasoning to make sure that our answer is correct. So we fill in all parts of the triangle. All the parts that I highlighted are filled. This question's done. We're not going to do this one because we kind of done 2 triangles already. So we're going to do a word problem and we're going to call her done here. So the base of the ladder on level ground is 1.9 meters from the wall. The ladder leans against the wall. The angle between the ladder and the ground is 65 degrees. How far up the wall does the ladder reach? So we're looking for that one. We are looking for how long the ladder is as well. So we don't need to solve the triangle, we just need to find these 2 measures. So let's start with angle G is equal to 65 degrees. We have our adjacent this time, which is 1.9 meters. We need to find our hypotenuse, which is FG, and we need to find our opposite, which is FH. So I have my adjacent, I need my hypotenuse, we're going to do cos again. So cos 65 is equal to 1.9 over FG. We're going to cross multiply. We'll get FG times cos 65 is equal to 1.9. We'll divide both sides by this to get FG by itself. So FG is equal to 1.9 divided by cos 65. Plug that into your calculator. You should get, to the nearest tenth of a meter, 4.5 meters. So we know that goes here. And I'll write a sentence. This tells me the ladder is 4.5 meters long. Okay, next one. I have my adjacent. I need to find my opposite. I'm going to use tangent. So that gives us tan 65 is equal to opposite over adjacent. We're going to cross multiply. That gives us 1.9 multiplied by tan 65 is equal to FH. We plug that into our calculator. And that gives us 4.1 meters is equal to FH. This tells us the ladder is 4.1 meters up the wall. Alright, hopefully that helps. Take your time, go slow, make sure you have everything solved for the triangle. Good luck.